Hi guys, I welcome you to this very interesting topic, alpha value and beta value computations. This is a very important topic in the finance courses, and through this presentation you will learn the computations, the comparisons, and it's going to be useful knowledge for you. So let's get started. So the alpha value is the difference between expected returns and required returns, and that is in a temporary phase in the price structure of securities. So remember that this is a temporary phase, and how this temporary phase will be over, that will be explained in this presentation. Okay, let's assume that markets are efficient, and in efficient markets the information relating to the stocks is available to the investors, so they are adequately compensated for accepting the systematic risk in an investment, and as such their expectations of returns and the required returns that is calculated, and it's a formula based calculation, there will be no difference, and therefore there will be zero alpha. So that means that if there is an alpha value, it means there is a difference between expected returns and required returns, and this difference represents arbitrage profit taking. So what is arbitrage profit taking will be explained later in this presentation. Now let's run through an example. Now let's consider two stocks, that is Mac and Rocker, and the beta values are given. You know, beta values are the risks associated with these stocks, and the expected returns are also given. So the beta value for Mac is 1.5 and the expected return is 18%, and for Rocker the beta value is 1.1 and the expected return is 18%. Now the market return is 15%, so that is the general overall market return, and the risk-free return is 5%. So the risk-free return is the return available on T-bills which are assumed to be risk-free security. So now the question is, what is investment advice? So let's proceed. So to provide the answer, we have to set up the alpha table, and as you can see, we got the two stocks, Mac and Rocker. Their expected return 18% for both of them, and the computation of required return is a formula based calculation. We got 5%, that is the risk-free return, plus, and within brackets 15%, that is the market return, minus 5%, the risk-free return, times the beta of Mac, which is 1.5, and the answer is 20%, and the alpha value in this case is minus 2. Coming down to Rocker, the expected return is 18%, the required return calculation is 5%, that is the risk-free return, plus within brackets 15% minus 5%, that is the market risk premium, times 1.1, that is the beta of Rocker, and the answer is 16%. The alpha value in this case is 2, and that is a positive 2. Now the advice is sell shares in MAC as the expected return does not compensate the investor for its perceived level of systematic risk. It has a negative alpha. So that is the advice as far as MAC is concerned. And then let's see the advice for Rocker. The advice is buy shares in Rocker as the expected return more than compensates the investor for its perceived level of systematic risk. It has positive alpha. Now this is a further discussion as far as the two stocks are concerned. The shares in Rocker had a positive alpha of 2%. This would encourage investors to buy these shares. As a result of the increased demand, the current share price would increase, thus the expected return would fall. And the expected return would continue falling until it reaches 16%. And that's the level of the required return, and the alpha value becomes 0. So now the opposite is true for shares with a negative alpha, and if you recall, MAC had a negative alpha, and the negative alpha will encourage investors to sell these shares, and as a result of the increased supply of MAC shares on the market, the current share price would decrease. Thus the expected return would increase until it reaches the level of the required return, and the alpha value becomes 0. So now there's another example. If the market return is 8% and risk-free return is 5%, the market excess return, that is RM minus RF, equals 3%, and this 3% is the market risk premium. So a portfolio with a beta of 1 should expect to earn a market rate of excess return equal to 3%. That is the market risk premium. 3% times the beta 1 gives you 3%. So continuing with the same data, if there is a fund with a beta of 1.5, should provide excess returns of 4.5, that is 3% market risk premium times the beta. And if actual excess return was only 4.1%, this means that the fund has a negative alpha of 0.4%. That is the difference between 4.5% and 4.1%. So the fund's performance is inferior to that of the market. Now, what we have done so far is summarized here, that the expected return of the portfolio is calculated as normal, a weighted average, and then we calculate the required return of the portfolio through the formula that you have just seen. And to do that, we must calculate the portfolio beta, which I'll show you in a minute, and then we calculate the required return of the portfolio using the CAPM, that is Capital Asset Pricing Model. Now let's run through another example. The data that is given here is that the expected return for MAC and Rocker is 20%. The market return is 15%. The risk-free return is 6%. And now we are given the proportion of the investment in the two funds. If 80% of your funds are invested in MAC and the balance in Rocker, the beta of MAC is 1.6 and the beta of Rocker is 1.1. and the requirement is to set up the alpha table for the portfolio. So the solution is here. We first compute the portfolio beta, and how we do that, we multiply the individual stock beta with the proportion of funds invested. So it is 1.6 times 0.80 plus 1.1 times 0.20, and that gives us the portfolio beta at 1.5. And now we use the similar formula for calculating the return, and that is 6% risk-free rate plus 15% market return minus 6% risk-free rate times the portfolio beta 1.5, and that gives us 19.5% as the portfolio return, and we plot that figure in the alpha table. So we got expected return 20% and the required return 19.5%, and the alpha value is 0.5%. The point to remember is that when the share price changes, the expected return changes, and therefore the alpha value also changes. So we can say that alpha values are as dynamic as the share price. So now the question of systematic risk as to what it is, what it represents, and how it influences the stock prices. So you know very well that these are market-wide factors, and the examples are the rate of economic growth, that is GDP, the corporate tax rates, the interest rates, the rates of inflation, the unemployment rates. So the systematic risk is always present in all portfolios and investments, but some investments will be more sensitive while others will have a higher systematic risk. Now we consider the calculation of systematic risk of an investment. The systematic risk is measured by the covariance of an investment's return with the returns of the market. So the systematic risk of an investment is calculated first. It is then divided by the market risk to calculate a relative measure of systematic risk. So this relative measure of risk is the beta, and it's represented by the symbol B with a little longer leg. And if an investment has twice as much systematic risk as the market, it would have a beta of 2. So now the formula for calculation of beta value is there, and the BE stands for beta of an investment in shares or equity. The COVEM is the covariance of returns on the shares with the returns on the market, and OM2 is the variance of the returns on the market, that is standard deviation squared. So this is the formula for computing beta of a stock or portfolio. There is another formula to compute the beta, and that is in front of you. So you can see that BE is equal to PEM OE divided by OM, where BE stands for beta of an investment in shares or equity, PEM stands for correlation coefficient, between returns on shares and the market. OE represents total risk, that is divided by standard deviation of returns on the shares, and OM is the total risk divided by standard deviation of returns on the market. So there is a question here. You are considering investment in rocks, and the covariance between the company's returns and the return on the market is 30%, and the standard deviation of the returns on the market is 5%. So we have to calculate beta value. So let's see the answer to this question. And the beta value is 1.2. How we got it? By dividing the correlation, that is 30%, by the standard deviation square, which becomes 25. So you divide 30 by 25 and you get 1.2. That is the beta in this case. So now there is another question here. The stock is max, and the correlation coefficient between the company's return and the return on the market is 0.7. The standard deviation of the return for the company and the market are 8% and 5% respectively. So the requirement is to calculate the beta value. So this is the answer to the question. We got 0.7 times 8% divided by 5%, and 1.12 is the beta in this case. So now we got the computation formula for coefficient of variation. It is abbreviated as CV, and it's a measure of risk. We divide standard deviation by the expected return. So the formula is CV equal to standard deviation divided by K, that is the expected return. So the coefficient of variation shows the risk per unit of return, and thus it provides a more meaningful basis for comparison when the expected returns on two alternatives are not the same. Let's see an example. So now we got the data for two projects, Project X and Project Y. The expected return for Project X are 60% and the standard deviation is 15%. And for Project Y, the expected return is 8% and the standard deviation is 3%. So the answer is we divide 15% by 60% to get the coefficient of variation as 0.25, and for Project Y we divide 3% by 8% to get a CV 0.375. So you can see that Y has more risk, although X's standard deviation is larger. Y has low standard deviation. It is riskier per coefficient of variation. And the coefficient of variation is useful where returns are different substantially. And now the CAPM formula. So you know CAPM, Capital Asset Pricing Model, the formula that we have used in this presentation, provides the required return based on the perceived level of systematic risk of an investment. And the formula is there. Required return is equal to risk-free return plus systematic risk premium. That is RA equal to RF plus B, and within brackets RM minus RF. So RA stands for required return on shares, RF is the risk-free rate of return, RM is the average return on market, and B is the beta of shares. And now this is an example and also a question for you, that the required return on the following shares is to be computed if the return on the market is 11% and the risk-free rate is 6%, and there are three shares X, Y, and Z, and the betas are given. For X the beta is 0.5, for Y the beta is 1, for Z the beta is 2. And let's see the answer of this question. So now the answer for stock X is 8.5%, and you can try your hand for stock Y and for stock Z. So guys, I hope you learned this concept of computing the alpha value and the beta value, the formulas, the computations, the examples that I gave you. I hope you understood them, and that gives you the basics to understand the concepts and to use them while attempting questions on stock valuations and investments. Please do subscribe this channel, press the bell icon, and provide comments for my encouragement. Thank you very much, and see you around.